Good evening, everyone, and welcome to the Spring 2020 Integrative Capstone Workshop Final Briefings. My name is George Sarah-Nicolau, and I will be hosting tonight's event. I work at the Earth Institute and have taught the Capstone Workshop. I'm also an instructor in the Sustainability Management Program. The Capstone Workshop is a key course in both of the programs that are represented in this event tonight, both the Sustainability Management Program as well as the Sustainability Science Program. It's a very special course because it calls on students to take everything that they've learned throughout their time in their respective programs and apply it in helping a client solve a sustainability problem. And you will see all of that knowledge and application and synthesis demonstrated as 6 different student teams make presentations tonight. These 6 teams of about 10 students each has worked with a faculty advisor to conduct a client-based project. These projects are for clients in government and the not-for-profit sector in both the United States and abroad. This evening is a very special one, not only because of the significance of the course, but also because a lot of the students who are participating here tonight are graduating next month. And so this is also an opportunity to showcase them and their accomplishments in the program and to celebrate their learning. It is also a special evening for us because this is the first time that the Sustainability Science Program participates in the Integrative Capstone Workshop Final Briefings. This is a young program, and this is the first time that the program has offered the Capstone Workshop to its students. And we will be hearing a fascinating presentation about microplastics in the Hudson River near the end of our program tonight. So with that, let me tell you a little bit about the format of tonight's event. There will be 6 presentations of 10 minutes each. I will introduce each one. After the presentation, we will take a few minutes of Q&A. I will ask the participants to use the chat to enter their questions, and I will read them aloud and give the presenter the opportunity to respond to them. So be thinking of questions and please type them in the chat so that we can make this session as interactive as possible, even though we're doing it online. Okay, with that, let's begin. Our first presentation of the evening is a very special one about bauxite mining in Guinea. The faculty advisor for this project was Professor Lynnette Widder, and our presenter is Cynthia Leung. Cynthia, take it away.
Cynthia, you're muted.
Thank you. It was good I didn't do the whole introduction there. Thanks, George. So good evening, everyone. I'll start over, but thank you for attending the final capstone briefings. My name is Cynthia Leung, and I'll be presenting our team's work tonight on stakeholder mapping and scenario analysis for the community-based assessment of bauxite mining impacts in Guinea. Our client this semester was the United Nations Development Program, referred to as the UNDP. It is the UN division charged with building local capacity to support sustainable development. All right, there you go. On our agenda tonight, I'll introduce the social and environmental impacts of bauxite mining in Guinea, explain the larger project that our capstone was a part of, describe how we tailored our solution and mission to address it, and discuss our key findings and deliverables. But first, let's get you oriented. The Bauxite region of Guinea is a relatively rural region on coastal West Africa and it is reliant upon subsistence farming for food and income. It also happens to be home to the world's largest deposits of bauxite. And for those who don't know, bauxite is refined to make aluminum. The process of extracting bauxite generates a characteristic red dust. This dust spreads through the air to sites through open pit mines and also spreads via transportation routes while being shipped in open cars and trucks. Bauxite dust is thick and acidic, and it suffocates crops and clogs waterways. Bauxite mining has changed the agricultural landscape and has impacted the economic welfare and health of Bokeh's communities. Although the country's laws require companies to file environmental impact statements, there is little accountability. Enforcement agencies are underfunded, and grievance mechanisms are also inadequate. A 2016 presidential policy accelerated extraction in the region, as seen in these satellite images. You'll notice mining roads pop up in a bright red color, as well as cleared land for open pit mines. All companies active in Guinea are partially owned by the country, but are run by international conglomerates. Fewer are publicly traded, and even fewer file CSR statements. In particular, Chinese-owned companies are highly secretive and are expanding most rapidly. Information sharing between mining practices, transportation, and oversight are highly limited and intentionally obscured. So our project supports the use of new remote sensing technology to facilitate greater accountability in the system. The technological and legal aspects of this project are under development by the researchers at Lamont Doherty Earth Observatory and at the Columbia Center for Sustainable Investment. Our capstone provides the base research and scenario planning for potential implementation of these new technologies. As we looked at this, we identified three primary sets of actors in the field. First was the residents of Bokeh, the government at an international, local, regional, and national level, and mining companies. Mistrust, lack of capacity, and poor monitoring have created dysfunction among all three groups. And we distilled the situation into four key problems. Pollution mitigation legislation exists, but is not properly executed. Information sharing among government, companies, and citizens is inadequate, and there are high barriers to access. Grievance mechanisms have not been effective, and compensation pathways for destroyed land are not equitably dispersed amongst and within communities. Our research offers a possible solution to some of these issues, and it foresees the development of an application that allows Bokeh's community members to record, locate, and map the presence of red bauxite hotspots by taking pictures through their cell phones. Using a smartphone app, actors on the ground could help identify these hotspots throughout the region, and this would help ensure inspectors could pinpoint when a mining operation was in violation of its permit. By cross-referencing these photos with satellite images, we create a robust information database that maps local mining impacts. And this technology will be tested in the field with 20 to 30 people in the winter of 2021, with the hopes of expanding it more broadly should the pilot succeed. The expansion requires clear flows of finance information, and our scenario planning focused on mapping how this could work. As a team, we recognize the implementation of this app would necessitate a basic scenario structure that would require an information database and three roles: data collection, data management, and funding. As you see here, the green arrows show the flow of funding or in-kind equipment, and the blue arrows show the flow of data. Our goal was to identify who might fit these roles. In order to address this question, we pursued three research methods. For the literature review, we completed desktop research of mining practices, governance structures, and health impacts from mining pollution. We compiled precedent studies of participatory tracking by existing NGOs, citizen science programs, smartphone applications, and existing mapping resources. But our most valuable insight came from interviews with Ghanaian stakeholders and experts from international organizations. We had originally hoped to fortify our research over spring break with in-person interviews in Bokeh. However, due to political unrest caused by turbulent national elections and a global pandemic, we were unable to complete what would have been a highly informative engagement with potential stakeholders. Given the new circumstances, though, we adapted. We recognize that there may be a lot of time between change between the completion of our capstone and the final implementation of the project. Considering this, we thoughtfully scoped out our deliverables to ensure they had utility well beyond the end of this semester. These included a database of synthesized information, which consisted of our literature review and key insights from interviews, stakeholder profiles, including government, community members, academia, and activists, and lastly, a series of implementation scenarios tied to the stakeholder profiles for piloting the app effectively. The latter two, which I'll further elaborate on, should be validated by on-the-ground research. We started by identifying 12 stakeholders. We then built out their profiles by evaluating their potential motivations and deterrents, and looked at their benefits and cost of their participation in the system. From there, we role-played each stakeholder, experimenting with what roles they might play, and developed scenarios that help explore the different sets of assumptions. We vetted each of these scenarios with our client, the UNDP, and arrived at 7 possibilities. I will focus on the one that they found most promising and most practical. Scenario 7, the technologically versatile and structurally connected. Our assumptions in this scenario were: 1, anonymity was important and that community members should be protected from retaliation from mining companies. The second was that NGOs provide organizational capacity for communities. And the third was that access to network connectivity and technology would be limited. We followed our basic structure necessitated by the app. And this scenario transfers significant roles in funding, data collection, and data management to Ghanaian stakeholders. And this way we could ensure longevity and sustainability of the project by creating a vested interest in the system. To ensure impartiality, we also included a role for an international agency like the UNDP or the World Bank, which has already funded sustainable mining projects in Guinea. So let's take a deeper look in this scenario to look at and start with the initial funding flow. Funding for data collection materials comes from the Ministry of Environment and the Chamber of Mines, which is an industry organization whose mission includes improving mining practices. These materials go to data collectors, likely at first to be community activists or local NGOs because they have the organizational capacity. Later, we do expect that community members can be recruited for this data collection role. As the data is collected, it gains value. It can be sold to, as the data is collected, it gains value, can be sold to mining companies and NGOs and consultants and other agencies through the information database that it gets put into. Here. And finally, what we liked most about the scenario was that the ownership of the data belongs to the people who collect it. The funds generated by the information database would cover the cost of the data management and be distributed into the community development funds so that they actually can fund community projects. This way, the people who collect the data and are impacted by it own the data and benefit from it as well. As we revisit our diagram showing the broken interaction between the government, mining companies, and people, the most recent scenario improves the overall transparency of the system. Environmental impact information sharing is improved by a verified body of evidence that is now owned and shared by the people. Communication and accountability between mining companies and community members improve the effectiveness of grievance mechanisms and equitable distribution of compensation. And lastly, pollution mitigation efforts will likely not see an immediate improvement from this project, but over time, as this database grows, it can serve as a foundation to reflect real effective policies that hold mining companies accountable in their operations. In conclusion, we believe that our well-documented database of research, synthesized interviews, stakeholder mapping, and implementation scenarios will help inform and orient future work by the research team once in-field work can be possible again. In this way, our capstone research has supported this larger effort in building an effective, transparent data collection process to inform responsible bauxite mining practices in Guinea so that truly benefits its local communities and its people. Thank you.
Thank you very much, Cynthia. Very good presentation. I'd like to invite questions now from the audience. You may use the raise your hand function to indicate that you have a question. Or use the chat if the raise your hand function is not immediately apparent to you. Cynthia, the first question comes from Suzanne DeRoche, one of the instructors in the program. She asks, as the project scales up and gets bigger, how do you ensure anonymity of community members, especially in light of selling the data or the prospect of selling the data to mining companies?
Yes, so I think I actually might have skipped that in our presentation, but what we're trying to do is ensure that both the Ghanaian University and the NGO, or like in the World Bank or the UNDP, really help manage the data. So by having this third party, like impartial party manage it, I think that's where we can ensure that there's anonymity in the data collection process so that by the time it goes into the information database, we can remove the information about the community members who participated in it And really what gets sold is purely the data that gets generated.
Okay. You talked a little bit about the effects of the pandemic on your project. Can you say what you were hoping to get that you weren't able to get in order to do this project? And you tell us a little bit more about that in detail. What were you hoping you could have done that you weren't able to do?
Absolutely. I think this is maybe a personal view, but I think with sustainable development, it's really important that you have on the ground experience and real exposure to the communities you're trying to support. And for us, really, we were looking towards a spring break trip to go to Guinea to really understand and talk to community members to say, what are the issues you actually have to deal with, like understand their living conditions and see firsthand what those parameters were. And if that was the big caveat to this project, was we could talk to as many people who have lived in Guinea, who have like been there, worked in legislation, and get all their impacts about how the systems work. But without us actually personally being there, I think that was a pretty big missing piece. And so for us, like, my biggest recommendation to any team doing this in the future is really to be there, be oriented with both the culture and the systems there to ensure that even every scenario we've thought out very heavily really does actually make sense.
Okay, Cynthia, wonderful. Thank you very much for this great presentation and this very interesting project. Congratulations.
Thank you.
So as we move to the second presentation of the evening, let me welcome the nearly 100 people who have joined us on this platform tonight. There are not only students who participated in this course, but there are many colleagues from throughout the Earth Institute. And we also have about 15 prospective students who are interested in either the Sustainability Management Program or the Sustainability Science Program. And I'd like to say a special welcome to them. Thank you for joining us. Our next presentation is about a project closer to home. The faculty advisor, as you see on your screen, is Professor Kizzy Charles-Guzman, and our presenter is Ashlyn Brulato. Ashlyn, welcome. Take it away.
Good evening, everyone. My name is Ashlyn Brulato, and I am presenting on behalf of my capstone team. This semester, we worked with the Environmental Defense Fund, EDF, to create a tool that will support a coalition of brands that are interested in using electric vehicles to tackle air pollution and greenhouse gas emissions from online shopping deliveries across the United States. For tonight's presentation, I will provide a brief introduction to the problem of emissions from last mile deliveries. I will describe our role and the deliverables requested by our client, discuss our methodology, review some of our project findings, and end by sharing a few recommendations and areas for further research. In 2019, US e-commerce sales were upwards of $600 billion and had increased 15% from 2018. This growing global e-commerce industry leads to more delivery vehicles on the road, which causes increased traffic congestion, increased emissions, and poorer air quality that negatively impacts public health. Transportation is responsible for 15% of today's global greenhouse gas emissions and is expected to be the largest source of new emissions through 2050, with 80% of that growth coming from shipping products and goods. The movement of goods from a transportation hub to an individual consumer is referred to as last mile delivery and is typically carried out on outdated fossil fuel intensive trucks. The focus of this capstone is to facilitate the replacement of those trucks with electric vehicles to reduce emissions and improve air quality. To address this issue, the capstone team was tasked with creating an emissions delivery model, a tool that finances, analyzes, and scales electric vehicles for e-commerce deliveries. The model we developed provides e-commerce companies, such as Macy's, referred to here as brands, with 2 co-financing options for how they can partner with carriers to deploy electric vehicles for last-mile deliveries. The team took a 4-phase approach to the emissions delivery model. First, we identified the key stakeholders in last-mile deliveries, which are brands, carriers, and cities. Next, we developed a benchmarking framework to identify the main enablers necessary for the growth of EV deployment in last-mile delivery. Then we identified 2 pilot cities for the model, New York and Los Angeles, which were chosen due to their large e-commerce footprint and poor urban air quality. Finally, we developed the model itself. The emissions delivery model is a tool that will help brands by measuring their current last-mile delivery emissions to help them set and meet their Scope 3 reduction goals, quantify the emissions reductions potential that would result from switching to electric vehicles, and helping them to understand the associated improvement in air quality, and comparing the cost of 1 diesel truck to 1 electric vehicle truck to determine 2 potential co-financing options that brands can use alongside carriers to accelerate electric vehicle deployment. The model first calculates a brand's current emissions from last-mile deliveries by using the number of miles a commonly used Class 4 or 5 delivery truck, for example, a step van, travels per year. By then converting to miles per gallon and using an established emissions factor, the team found the typical emissions from 1 diesel truck are almost 17 metric tons of carbon dioxide equivalent in both New York and Los Angeles. To calculate the emissions reductions potential from switching to electric vehicles, the same methodology was applied. To find the emissions from an electric vehicle, the team used an average kilowatt hour per mile conversion factor. The emissions factor that was applied depends on the local electricity mix. Therefore, the emission savings are slightly different in New York than in Los Angeles. In Los Angeles, there is a 74% reduction in carbon dioxide equivalent by switching to electric vehicles. In New York, the savings potential is 69%. After an extensive literature review and conducting interviews with industry professionals, the team decided on 2 potential financing mechanisms that brands can use to accelerate electric vehicle deployment. The models are referred to as A and B, and represent a power purchase agreement financing structure and a lease structure of EVs. In Model A, it is based on a typical solar power purchase agreement. In this scenario, carriers agree to purchase and operate electric vehicles and receive a return on their investment by charging brands for each pound of package that is delivered on an electric vehicle. The second model is based upon a lease. In this model, a brand agrees to pay a carrier a fixed monthly payment as opposed to a payment per pound of cargo. The carrier, in turn, leases an electric vehicle from a leasing company. It is important to note that the team created Model B, the lease-based model, after interviews with an established EV leasing company. However, their leases are currently only available in Los Angeles due to a variety of state, city, and utility incentives in California for the purchase of electric vehicles. Therefore, for the sake of time, I will only walk you through Model A, the PPA model. In Model A, carriers provide the upfront capital and of the vehicle and charging infrastructure, but receive a return on their investment by charging brands on a per pound basis. To calculate the PPA rate, the team first included calculations to determine the total cost of ownership for both a diesel and electric vehicle truck. This was done for both cities using an assumed lifetime of 12 years. The parameters of the total cost of ownership included calculations associated with the following inputs: the vehicle purchase costs for both diesel and electric vehicle trucks in Los Angeles and New York City, the availability of city, state, and utility incentives for the purchase of electric vehicles, the projected total annual fuel costs, the assumed lifetime maintenance costs, and any infrastructure costs and their associated rebates. Using an average of 500 pounds of cargo per day and 300 operating days per year, the team determined a cost per pound price for diesel and electric vehicles in both Los Angeles and New York. The price was based off of the net present value of the cash flows over the 12 operating years using a 5% discount rate. As you can see in the figure on the screen, deliveries from electric vehicles are 11 cents cheaper than deliveries from diesel in LA, but actually 4 cents more expensive in New York City, highlighting the importance of financial incentives for electric vehicles. Considering the high cost of financing electric vehicles for a single brand, the team proposes that multiple brands form a coalition to reduce their individual financial contribution. We modeled what that might look like for 5, 10, 20, and 30 brands and found significantly lower cost per pound in the PPA model through brand collaboration. There are many additional benefits that each stakeholder would receive from the use of the emissions delivery model. For example, brands would get closer to meeting their sustainability goals, see increased industry collaboration, and reduce their downstream Scope 3 emissions. Cities would see improved environmental outcomes, better air quality, and reduced Scope 1 and Scope 3 emissions from in-boundary and out-of-boundary transportation. And carriers will improve their competitive edge, see reduced fuel and maintenance costs, and minimize their Scope 1 or Scope 3 emissions, depending on if they choose to own or lease electric vehicles. Moving forward, more investment is needed in greening the energy grid to truly make electric vehicles zero emissions. Additionally, cities, states, and utilities can increase the number of public incentives available for financing electric vehicles. Finally, quantifying the long-term improvement in air quality that would result from the use of electric vehicles is beyond the scope of this model. To make this quantification, more research is needed to identify EV charging patterns and the impact of charging infrastructure alongside the natural changes in air quality that occur seasonally. Overall, the Capstone Group successfully identified ways to accelerate electric vehicle adoption in last-mile deliveries through the development of the emissions delivery model. This model will support brands in partnering with carriers to substitute diesel trucks with EVs. If adopted, the model can contribute to improved urban air quality, better environmental and economic outcomes for all stakeholders, and a significant reduction in Scope 3 emissions for brands. Thank you for your time today. The team is grateful to have contributed to the thought-provoking research on electrifying transportation. I am looking forward to hearing and answering your questions at this time.
Thank you very much, Ashlyn. Nice job. I'd like to, again, invite questions for Ashlyn, and there are two ways to ask your question. The easiest and most interactive would be if you use the raise your hand function on Zoom, and this way I would be able to call on you and you would be able to speak your question to Ashlyn. Alternatively, you can use the chat function and then I will read the questions to her. So Ashlyn, we have a couple of questions coming in on the chat. Let me tell you what they are. Catherine is asking if you could please go a little further, give us a little bit more detail as to why you chose New York City and LA as the two cities to examine.
Great. Sure, I'm happy to expand upon that. So through our benchmarking framework that I mentioned in our methodology, we actually identified a variety of factors that would make a city both equipped to support electric vehicle deployment, but also in need of electric vehicles. And so we looked kind of at what the established EV penetration is in the city, definitely at the financial incentives, as well as the energy grid, as we wouldn't want to be minimizing urban air pollution, but causing an increase in air pollution elsewhere, significant increase, any policies and greenhouse gas reporting in the city, and then also population density as a proxy for congestion. And then of course, urban air quality was an important factor, as this was something that our client was hoping to tackle, as well as reducing emissions.
Okay, let me just once again remind the audience, you can use the raise your hand function, or you can type your question in the chat. The next question, Ashlyn, comes from Professor Widder, who has a related question to the previous one. about the model and whether it includes factors having to do with urban planning and traffic congestion. And if not, if the model doesn't account for those things, then she asks whether the only work then needed to apply the model to other cities is to look at those cities' energy, electricity mix.
Sure. So we didn't actually include congestion or urban planning factors into the model, only into the process for the benchmarking. So we do have a list of other cities that could potentially be good fits, or cities that could learn what they could do to promote last mile deliveries. But for the sake of the actual model, we would use the energy mix, and then the brands would input their own data, such as how many pounds of cargo they are delivering and how many days they are typically delivering per year.
Okay, Ashlyn, congratulations on completing this project and on a very strong presentation. Thank you very much.
Thank you.
All right. We will now move on to our third presentation of the evening. As we get ready for that presentation, let me encourage the audience to ask questions and to participate as much as possible. Let's work together to make this event as interactive as possible and to try to simulate normal conditions to the extent that we can. Our next presentation has to do with wildlife. The faculty advisor was Professor Dr. Bob Cook, and Alison Kelman will present. Welcome, Alison.
Thank you very much. I'm just making sure this works here. Come on. Let's see. There we go. Sorry about that. Hi, everyone. My name is Alison Kelman, and I am the Deputy Manager for our Capstone group, which is titled, Do Biodiversity Metrics Positively Correlate with Environmental Well-Being and Economic Indicators? Our team comes from a variety of backgrounds, including data analysis, food systems, conservation, and more. Our group manager is Annie Nichols, and our faculty advisor is Dr. Robert Cook. Oops, shoot. Here we go. Our client was the International Fund for Animal Welfare, or IFAW. IFAW is an animal welfare and conservation charity that works to rescue animals, safeguard populations, and preserve habitat. The goal for our work was to determine if biodiversity metrics correlate with country well-being indicators. If so, IFAW would be able to use these results to inform more effective policies to preserve biodiversity. So in order to best assess the relationship between wildlife conservation and well-being, our team evaluated existing biodiversity data sets and established well-being indicators to define the relationship between the two. If a significant relationship was found, IFAW planned to use the data to strengthen their case for more wildlife protection policies. Strong policy measures that work to protect the world's biodiversity are more important than ever, as we live in an era where 70% of all species are at risk of extinction by 2070. From the onset, we divided our approach into 3 phases: initial research, data collection, and synthesis of findings. Phase 1 in our approach was to research all existing indicator sets for human well-being. The team collected a comprehensive list of indicators through literature review and interviews with experts and biodiversity experts and economists. In phase 2, we compiled the data from selected data sets into an Excel document, then ran a series of regression analyses to compare indicators and assess their relationship. In phase 3, we synthesized our findings and compiled further recommendations for IFAW's policy team. So in phase 1, our research team split into groups to compile a list of all substantial existing global wellness indicators and a separate list of biodiversity metrics. The ideal indicator sets covered a large number of countries, were updated frequently, and incorporated health, happiness, education, environment, and economic data. We then reviewed this list with IFAW as well as other experts. In the initial review, we filtered out weaker data sets and kept those that included broad numbers of countries and higher levels of detail. In our final list, we decided on 4 well-being indicator sets and 6 sets of biodiversity metrics. In phase 2, we ran a series of regression analyses between all 4 well-being indicators and all 6 biodiversity metrics to produce 24 regression analysis graphs. These visually portray the correlation, which is defined as a statistical technique that can show whether and how strong pairs of variables are related. These graphs provided our team with a visual comparison of the data, as well as a calculation of the correlation, or R value. This is a sample of a regression analysis. The image on the left with the green dots represents a strong positive correlation, while the red dots on the right show a weak correlation. R values are presented as a value from -1 to 1. The closer to -1 or 1, the stronger the correlation. -1 means the correlation is inverted, and if it's closer to 1, then the correlation is positive. If the R value is 0, it means that the correlation is weak. So our regression analysis showed that the Ocean Health Index moderately correlated with selected well-being indicators, and the Ecological Footprint Index showed a slight negative correlation. The remaining indicator sets showed no correlation. The strongest correlation of 0.64 appeared between the Social Progress Index and the Ocean Health Index. And the Social Progress Index strives to reflect the social and environmental health of societies. It includes 51 data sets divided into 3 categories, which are basic human needs, foundations of well-being, and opportunity. Specific data inside these categories include items like basic medical care, shelter, personal rights, access to advanced education, and many more. The components of the Ocean Health Index are compiled into scores that aim to reflect the ability of the ocean to benefit people now and into the future. The scores are compiled from dozens of components, which include measurements of species health, pollution, economic benefits, all derived from the ocean. In this regression graph, you can see what the correlation of 0.64 looks like. As you can see from these data points, countries that scored highly on the Social Progress Index tended to also score highly on the Ocean Health Index. However, this was the only data set out of 24 that showed a moderate and positive correlation. An example of another regression we ran was between the Human Development Index and the IUCN Red List of Threatened Species. The Human Development Index is a summary measure of items like having a long and healthy life, being knowledgeable, and having a decent standard of living. The Red List is an index of survival probability, or the inverse of extinction risk. This is for all birds, mammals, amphibians, and more occurring within the country or region. Here you can see the results of the regression analysis between the Human Development Index and the IUCN Red List. In this case, the R value is 0.04 and shows almost no correlation at all. Our findings from the regression analysis concluded that there are no strong correlations between any well-being indicators and biodiversity metrics. Though we found a moderate correlation between the Ocean Health Index and other well-being indicators, and a moderate to weak correlation between the Ecological Footprint Index and multiple well-being indexes, we felt that they were not strong enough to use as a basis for policy change. While the Ocean Health Index showed a positive correlation, it only covers one specific biome and so lacks broad application. The remaining comparisons showed no correlation. So given the lack of correlation, and in order to assist IFAW in their mission to propose and pass further biodiversity protections, we decided to do additional research into existing innovative biodiversity policies. We switched gears from quantitative to qualitative analysis, searching for examples of countries that might not have high levels of biodiversity, but are doing things to protect the biodiversity that they do have. We identified which countries scored highest for both well-being and biodiversity by comparing the IUCN Red List and protected area coverage to the Human Development Index. The majority of these countries are wealthy European countries who in all likelihood have the resources and stability to prioritize protections. We selected Norway and Germany as they scored highly on both lists. So for example, in 2002, Germany adopted the Federal Nature Conservation Act, which designated different land protections across the country. As of 2018, over 37% of German land is now under some form of federal protection. let's see, and now in 2007, Germany developed their national strategy on biodiversity, which outlines 400 different social, economic, and environmental measures for both government and non-government organizations. Norway's unique approach to biodiversity protections are driven both by economic and cultural factors. Culturally, Norwegians have embraced a philosophical lifestyle that is based on spiritual connected to the landscape. This is referred to as friluftsliv. In addition to cultural drivers, seafood exports employ over 28,000 Norwegians and account for over 39 billion in exports. Protections for sustainable fish stocks include discard bans and strict caps on total allowable catch per species per year. Our primary challenges were finding data sets that contained high quality data and included the majority of the world's countries and were updated regularly. We were forced to reject certain data sets when the raw data could not be attained or contained a high paywall. Each indicator set was collected and arranged by a different entity, which meant that formatting the data took some time. Additionally, we were unable to compare specific biodiversity metrics with specific indicators within an index. For example, the Social Progress Index has 51 indicators within it, making it impossible to compare biodiversity metrics to more narrow well-being indicators such as migration, education levels, or income. In conclusion, our group found a minimal correlation between well-being and biodiversity indicators. These results reveal the complexities of data and uncontrolled variables. These comparisons also make clear that wealthy developed countries are more likely to rank higher in both biodiversity metrics and well-being. We advise that IFAW direct their research to focus on individual happiness derived from biodiversity. There's a growing body of research dedicated to the connection between mental health and access to nature, as well as productivity and access to nature. As a next step, we recommend that IFAW look into incorporating biodiversity into these studies. Thank you very much.
Thank you, Alison. Good presentation. If you have questions for Alison, please either use the chat or the raise your hand function, and Alison will ask them. Alison, the first question comes from Dr. Alex de Sherbenen, who says that, as you know, correlation is not causation. And he asks whether you have an explanation as to why the Ocean Health Index correlated strongly with the corresponding economic index.
That's a good question. I'm not positive, and we didn't dig into it too much. I think the Ocean Health Index had a really wide variety of data sets within it. It covered species health, pollution, but also had a lot of economic factors within it. So it had a pretty wide, a pretty broad topic base sort of in it. So it was really difficult to figure out exactly what it was about that particular index that that had a high correlation. So I don't have a great answer to that, just because a lot of these indicator sets cover so many different things. In a perfect world, we'd have a little more time and we'd be able to parse out individual indicators to try to narrow down on other sets that might actually be in line and have a connection.
Alison, let me ask you my question. Your findings seem to me to be counterintuitive. You would think that in places where biodiversity was high, where countries ranked high, people would also be enjoying relatively good lives because the environment would be protected, and the country would be sensitive to environmental conditions. Why do you think that the correlation is weak in the other 23 pairs of indicators that you compared?
Sure. Well, we have sort of a few different ideas around it, but I think what is not shown or not really included in the study is a timeline. So in the history or the progress of developing a country, it takes a lot of time to get to a point of stability where you can afford to implement protections, where you can afford to put biodiversity ahead of immediate human need. So when you look at a lot of the countries that have high levels of biodiversity, oftentimes they're closer to the equator, and more often than not, they are countries that are still developing. And so what we found often was the countries that rank highest in well-being or happiness are often in countries that just at this point do not have high levels of biodiversity. So like Norway and Germany don't necessarily have high levels, but they're able to afford to protect what they do have. So we have a couple different theories on why the framework of this didn't come out the way that we expected or the way that IFAW wanted it to. But I think we all felt the same way, in that we think that there's more to dig into to figure out where that correlation is, because I think preserving biodiversity, there's certainly a connection between well-being and biodiversity, but I don't think that we were not able to find it in the framework for the way that we did this project.
Okay, and finally, can you explain your recommendation at the end to your client to turn its attention more to individual measurements of happiness? What's the difference between the indices that you looked at and this individual measurement of happiness?
Sure. So there's a growing body of work that's happening now where scientists are studying individual mental health and access to nature. So how much time you get to spend outside, and also what that outdoor access looks like, what the quality of that outdoor space is. And there's a lot growing with mental health, productivity, even healing. So I think that body of work, it's much more individual. You'd have to study, specific people rather than countries as a whole, or indicators, sets of indicators, looking at the direct benefits of access to nature, and then hopefully incorporating biodiversity into that definition of nature. So that's been growing.
Thank you very much, Alison. Congratulations on a successful project and a good presentation. Good work. Okay, we go on to the fourth presentation of the evening. So far, you have been listening to presentations of student teams from the Master of Science in Sustainability Management. And the next one comes from this program as well. You will notice that our students are able to take on a diverse set of sustainability problems. We began the evening with a presentation about bauxite mining and citizen science. You have heard presentations so far about electric vehicles and CO2 emissions. Just now, one about biodiversity and economic analysis. And now we turn to a more local concern about the transition to renewable energy in rural places in New York State. And so I'd like to invite the next presenter. The faculty advisor for this project was Thomas Abdallah, and Mehul is going to give us, Mehul Dalal is going to give us the presentation. Welcome, Mehul.
Hey, thank you, Professor Sarah-Nicolau.
Mehul, we can not hear you so well. Could you please speak a little bit louder?
Hi, Professor Sarah-Nicolau. Can you hear me? So I think the audio is kind of a little bit trouble on my end.
Mehul, we're having trouble hearing you. If you can hear us, please start over and speak as loudly as you can into your mic.
Hi, are you able to see me now?
Yes, go ahead, Mehul.
Okay, great, thank you. Thanks for the introduction. Sorry for the tech difficulties. Good evening, everyone. I'm Mehul Dalal, and today I'm humbled to be telling you a story about an agrarian society left behind, taking new routes into a bright, energetic future. The growth of a clean energy future in the Genesee-Finger Lakes was inspired by Professor Thomas Abdallah, orchestrated by Daniel Schab, and is the creative works of Jensen, Karen, Lauren, Leo, Kevin, Tejaswini, and myself. The Genesee-Finger Lakes region of New York State, located about 250 miles northwest of Manhattan and bordering Lake Ontario, has seen gradual economic decline over the past 30 years. Manufacturing companies downsized in the 1980s, which has pushed local communities to fall back on their origins of producing wine as well as dairy farming. These local communities are in dire need of systemic change for economic revitalization. The Genesee-Finger Lakes Regional Planning Council recognizes this and is working with NYSERDA in order to find unconventional solutions to bring to the region. Their intention is to use the clean energy transition to kickstart economic growth. While many welcome the clean energy transition with open arms, a subset of the population voiced a concern in its implementation. Many see the transition as a direct conflict with key economic activities, since much of their livelihood depends on agriculture and tourism. The region is full of landscapes that have supported these industries, as well as bodies of waters that have enabled nuclear and hydroelectric generation to become key parts of the current energy portfolio. They're considered zero emission and factor into New York's 2040 emissions reduction goals, but the sources are primarily provide baseload power. Fossil fuel dependent generation is unfortunately still a large part of intermediate and peak power demands. Buildings rely on fossil fuels as well for heating and cooling. Outdated building systems create high annual costs in a climate of hot summers and below freezing winters. Transportation also relies heavily on these fuels for the exportation of goods and vehicles that locals use to get around. Overall, fossil fuels are a liability for the region. They are vulnerable to global price fluctuations, expensive to operate, and are a detriment to the environment. The people of the region stand to benefit from a change in the way energy is generated, distributed, and consumed. The region has the opportunity to bring the chapter of fossil fuels to a close and begin a new one through the development of a sustainable energy economy. With plentiful sunshine, wind, and livestock, there are many opportunities for renewable energy to be adopted. Solar and wind generation paired with biofuels can provide clean and flexible generation and local energy independence to the region. Reducing consumption demands by retiring energy-intensive assets will lower the overall amount of new generation sources needed. Communities should update their energy codes to reduce the overall footprint of heating and cooling buildings through electrification. Investments in electrified long-distance railways will provide reliability and stable pricing for exportation of local goods as well. EV public transportation and an expanded charging infrastructure can also support locals and tourists alike. With these transformative objectives laid out, those whose livelihoods would be affected have concerns about their implementation, understandably so. With the natural beauty of the region's environment being a point of pride for the residents of the Genesee-Finger Lakes communities, there's often debate on the subject of building more physical infrastructure. Communities are fraught with legitimate anxieties about how the introduction of new energy technologies will affect their agricultural economy, land use, and water needs, as well as how it will affect the alluring aesthetic and nature of its pristine landscapes. Misconceptions on the transition are also a big part of the cultural attitude of the region. For example, since birding is a common recreational activity which draws tourists, many stakeholders are concerned about the scale of impact that wind turbines will have on bird deaths. In reality, house cats alone kill significantly more birds per year than wind turbines, as seen in the data from the U.S. Fish and Wildlife Service. The concerns of stakeholders are not unwarranted, but they can be addressed through mitigation and education. There are many techniques available to avoid changing the character in the region. They include creating incentives to sway renewable developers towards infertile agricultural lands, brownfields, and transportation and transmission corridors. This also means creating regulations such as requiring donations to tree banks for tree clearing and requiring visual impact assessments, which call for trees to be planted to hide solar panels from passerby. With their concerns at the forefront, the region's community members will be more invested in supporting the effort. Even granted community buy-in for the general energy transition, there are many hurdles to overcome that will require collaboration between developers, utilities, regulatory bodies, and community leaders. The local community needs to be educated and aware of the changes that they will see, as well as be given the opportunity to lend a hand. For the boom of renewable energy projects continues, it is also necessary to bring transmission infrastructure up to more modern standards. Streamlined renewable energy development laws will also support deployment. Although there will be difficulties in implementing a clean energy transition, there are resources already in place to help support the transition. Through interviews with organizers of clean energy initiatives, there was gained an understanding of best practices and lessons learned. In the Mid-Hudson region of New York, collaborative group learning and knowledge sharing at monthly meetings provided to be highly effective in encouraging energy efficiency upgrades. In Grand Rapids, Michigan, the importance of stakeholder engagement and intentional planning was all too clear when initiating landfill solar project development. And in Palmer, Massachusetts, a conversation with the town planner revealed the importance of messaging to achieve community buy-in for sustainable building code updates. It is clear that this is the direction that communities across the country are going, which are examples that the Genesee-Finger Lakes region can also similarly stand to benefit from. At the federal level, there are several tax credits, loans, and grants available for qualifying renewable energy technologies and projects. There's also financial assistance and regulatory support in development at the state level. For example, Article 23, a recent amendment to Article 10, is designed to streamline permitting processes of large-scale renewable projects in New York. While this is an example of forward-thinking legislation, it actually preempts local authority in some cases, so communities might need to find alternative means to protect their interests. The differing motivation factors and values between the state and local community members pose a challenge to the clean energy transition. However, the Genesee-Finger Lakes region has advocates that can aid it in finding balance through this, and they can look into other regions that have faced similar challenges and can serve as touchstones. By implementing this transition, the region can see new jobs based in renewable energy brought to the region, a reduction in air pollution, and an offsetting of greenhouse gases. Additionally, healthcare systems will see relief due to reduction in respiratory and cardiovascular disease. With tourism in mind, the growth of ecotourism that the clean energy transition offers is another clear win for the region. Of course, there is the bigger picture to consider. Through the implementation of the transition, the Genesee-Finger Lakes region can help support state, national, and international goals related to stopping and reversing climate change and making the world a better place for future generations. So one might envision a resident of the Genesee-Finger Lakes facing financial hardship inspired to lead a clean energy transition within their community, or maybe just their own backyard to start. Without giving up their agrarian roots, they can generate additional revenue on underutilized land, save on energy costs, and live a low-carbon, energy-independent lifestyle. Through this story and available comprehensive guide, the people of this region will be empowered and educated to realize the numerous benefits of the transition. In the coming decades, agriculture in this region can be sustained alongside the generation of clean, cheap energy. Biodigesters will create closed-loop systems for agricultural waste. Buildings where residents work and live will have minimal energy waste. And electric vehicle networks will expand to provide cheaper, efficient transportation. It all starts now. every single actor in the region has the potential to sow the seeds of change today and will grow into a clean, bright, and energetic future tomorrow. Thank you. Does anybody have any questions?
Thank you very much, Mehul, for an interesting presentation. I'd like to invite all of our audience members to either use the chat or the raise your hand function to ask a question. So we have a first raised hand, which is very exciting to me as the host of this event. And so let me call on Professor Widder to unmute her microphone and to turn on her video and ask her question.
I probably wouldn't have raised my hand if I knew you were going to ask me to turn on my video, but why not? All right. Thank you, Mehul. I had a question which probably comes from my background in built environment. You spoke about 3 types of land as being ideal for alternative energy development: infertile fields, brownfields, and transmission corridors. I know that New York State and NYSERDA have been eyeing this region because they have a downstate consumer of energy, and this is a less populous area. I'm curious whether in your research you found any mapping exercises or whether you contemplated them yourselves to look at the overlay between agriculture, sort of different land uses, and the kind of sort of the potential and location of the best sites for alternative energy development as a way of incentivizing communities to be more interested.
Yeah, thanks for your question, Professor Widder. So yeah, we did look into some mapping exercises. So what we kind of found within the region itself was when we did some GIS analysis of looking at where brownfields were located and where utility lines had like capacity to interconnect, and as well as like reduction of like lesser amounts of wetlands located within parcels of land. Those were typically the areas that were most desirable for renewable energy development. The region itself in the mapping exercise found that there were actually a lot of brownfields in the Genesee-Finger Lakes region. So we weren't able to like cross with like what areas the developers were actually constructing on, but we do believe that there's significant opportunity within the Genesee-Finger Lakes region based on how many brownfields we saw there.
We have yet another raised hand from Professor Suzanne DeRoche. Suzanne, go ahead.
Thanks, George. Thanks again for the presentation. So in preparing guidance that NYSERDA could use to help communities better understand the benefits, did the team look at estimating any of those specific benefits for the region, such as, you know, what is the potential for green jobs in that region as a way to bring some of those communities forward? And I'm interested in sort of what is the magnitude of those benefits as those projects start to be implemented?
Yeah, thank you, Professor DeRoche, for the question as well. So we didn't do like an in-depth analysis of like what type of job opportunities or how many would come into the region, but what we did look at was like how many jobs in the region were related to solar in present time, and like approximately how much they were earning. I don't recollect the exact numbers, but I know the jobs were earning somewhere around like $60-some thousand. And then I think the average median salary I'd mentioned at the beginning of the presentation was like 40,000. So they seem to generate a significant more amount of income. And then as far as the number of jobs that were available, there's definitely a graphic in the report. I just don't remember the numbers and I don't want to quote it without looking at the graphic. But yeah, we did look into it.
Thank you.
Mehul, Katie's asking whether you looked at land outside of farmland that could be considered viable for solar projects. And outside of farmland, she also means beyond brownfields and other infertile land. Are there other types of land that could be used?
Yeah, thank you for the question, Katie, as well. So yeah, there's definitely other lands that can be used. One of the key ideas with using these infertile lands, brownfields, and transmission corridors is that like tree clearing wouldn't be required. And we've just kind of felt that like building renewable projects, even if they're offsetting more carbon within their operation period or lifetime than their trees would in that same location, it just didn't seem like it just didn't seem right that we were like clearing trees to do large-scale renewable projects. So that's why we targeted those three major areas. Some other ones that are sometimes of interest are like large parcels of land, such as like golf courses, where the landowner no longer wants to operate the golf course. That could be turned into a large-scale utility project. We saw that in some areas in Long Island, New York. So yeah, there's definitely other options, but that was the reason why we targeted those three.
And then a final question about using brownfields for renewable energy. Are there any environmental impacts that we should be concerned about when working on brownfields?
So it's not something we specifically looked into, but I mean, I guess like through the studies of my program, my understanding of brownfields, which might not be that thorough, would be that like the lands already have like potential environmental issues, known or unknown. It's kind of taken over, and then a renewable energy project is built on it. If anything, the developer will have to clean up the environmental issue that was there from before. And if there weren't any there, the new project that would be built on the site would create no additional environmental impacts, except for like standard things like stormwater runoff and things like that. And that's like standard regardless of which type of land mass that is being used for the renewable project.
Thank you very much, Mehul. Congratulations on completing your project. Congratulations to you and your team. Okay, so let's move on to the fifth presentation of the evening. Remember, we have 6 altogether. You have been hearing presentations from teams of students in the Sustainability Management Program. Next, we will hear about the youth movement and its activism around climate action and how that figures into cities' planning for climate action. Our presenter is Alyssa Blumenthal. Welcome, Alyssa, and take it away.
Great, thank you, George. And thanks everyone for being here. As George mentioned, my name is Alyssa Blumenthal, and I'm excited to be presenting tonight on behalf of my capstone group. And we'll be spending some time exploring our research on how youth climate demands can be integrated into city climate action planning. And I want to start by discussing why we should care about youth in climate work. Put simply, because they're not willing to be ignored. So all over the world, millions of young people have been inspired by the 16-year-old Swedish climate activist Greta Thunberg, and they're taking to the streets in protests and demonstrations for climate action. They understand the scientific projections, and they're terrified about their futures. And they're outraged as well by a perceived lack of action by people they think should be leaders in this area. And in that, they're supported by scientists, by teachers, and by parents. Given that, the purpose of this project was to help understand what drives these youth and what key messages they want incorporated into city climate action planning around the world. Once we understood their demands, our goal was to assess whether these demands are or even could be addressed by city climate action plans, as well as to identify opportunities for cities to engage more deeply with their young constituents. Our client was C40 Cities Climate Leadership Group, which was founded in 2005 with a goal of equipping and empowering city governments to lead the fight against climate change. From New York City to Buenos Aires to Jakarta to Amman, C40's influence is impressive. Its network of cities represents over 650 million people and a quarter of global GDP. Together, C40 and its member cities are building the case for climate action, not only because climate action is important, but also because they see it as an important way to expand economies, to create jobs, and to improve cities as places to live and to work. Today, through its Deadline 2020 program, C40 is supporting more than 96 of the world's most innovative and biggest cities as they review, update, and adopt integrated, inclusive climate action plans, called CAPS for short. In CAPS, and we have a couple examples for you on the screen, cities align with the Paris Agreement, and they lay out their plans for low carbon and climate resilient development. To guide our research, we asked 3 key questions. First, who makes up the youth climate movement and what do they care about? And then next, how do the demands of youth climate activists compare to the actions that are being talked about in city climate action plans? And finally, to what extent are these youth demands being incorporated into CAPS? And if they're not, could they be? To answer these questions, we started by defining a youth climate group, and then we selected a sample of youth groups to research. We used publicly available information like websites and social media to itemize demands from a total of 28 youth climate groups spread across the world. We also then conducted interviews with 15 youth climate activists. And the goal of this was to get more insight into how youth think about government and climate solutioning, as well as how they want to be included by cities and by governments. To compare what we were hearing from youth with city climate action plans, we then reviewed 21 complete and incomplete CAPs. And like with what we did for youth demands, we cataloged each of the actions being laid out in the city climate action plans, creating a data set of all the youth demands and all the city action demands for our sample. We knew it would be challenging to develop guidance based on particular and often specific youth demands. So for our analysis, we grouped demands by theme. And this helped us identify key issues driving youth voices. And we used the same set of themes to categorize youth demands as we did for city actions to help us identify gaps and overlaps in the topics being discussed by these 2 groups. We also analyzed how youth and cities discuss mitigation and adaptation, and we used a language analysis to get a little more insight into communication and potential communication gaps between youth and cities. Across the 28 youth groups that we looked at, we reviewed a total of 251 demands, and we found that youth care about a wide range of issues. So some are specifically climate related, which I would say is pretty expected, but interestingly enough, many others aren't. So a 5th of youth demands focus on climate and social justice, and other top demands are tied to stakeholder engagement, to education, and to government policy. And these are all more structural than what you'd think of as traditional environmental issues. Youth care about these environmental issues too, of course, but they talk a lot about overarching engagement concerns. This was also something we heard about in our interviews, and where youth told us how they depend on partnerships with their peers and fellow youth groups, as well as with NGOs and other institutions, and even sometimes governments. And I personally think an interviewee from South and West Asia may have said it best when he said, there is no point talking about who does what. It's more important that we all come together to find solutions. We also reviewed 161 city actions in the climate action plans of our sample. And we learned that, as it turns out, CAPs do incorporate many of the issues that youth care so passionately about. In fact, besides education, 4 of the top 5 themes we saw in youth demands are also in the top 5 list for cities and their climate action plans. But something we realized was that youth and cities don't always talk about these issues in exactly the same way. For example, for many of today's youth, climate change activism is fundamentally incomplete without incorporating broader social justice goals. When talking about climate justice, youth explicitly demand racial, gender, social, and economic justice and inclusion. But when cities talk about climate justice, they tend to do it in much broader terms. And similarly, on the topic of education, this is less of a priority for CAPS, but some CAPS do address it. But when they do it broadly. Youth go a lot further. They speak to formal education curriculum changes, they speak to informal education, and they want everything from reforming school education to demanding that every politician take a climate science test. But one thing that they do is they send a consistent message that education is a key tool for successful climate action. Now, on the communication side, we found that youth speak with an urgency and a vigor that's not found in most CAPs. It's an emergency. Youth want action now. What this tells us is that even though most cities and youth are talking about the same key issues, city climate action plans may not be suited to address all youth needs, like this need for immediacy. But even so, our research tells us that CAPs are suited to address a number of key youth issues, and that there are meaningful and short-term immediate ways that C40 can take steps to leverage CAPs as tools for increased youth engagement. And we want to talk through some recommendations we have on that now. Our first recommendation is that C40 encourage its member cities to specifically include youth in CAP stakeholder discussions. CAPs discuss stakeholder engagement, but many youth don't feel that all communities are represented as part of this process. They want to see more inclusive and diverse stakeholder engagement. And CAPs can and should be a tool for achieving this, particularly because there are some CAPs that are already doing it. For example, Auckland has a goal committed to youth and intergenerational equity, and Rio de Janeiro discusses educating youth for resilience. Building off this, C40 should also encourage its cities to connect climate issues to broader social justice initiatives. We know that many cities care about social justice and they talk about it, but this story isn't told in CAPs, even though it's a story that youth climate activists want to hear. With that said, CAPs either need to be more specific when they discuss equality in the CAP itself, or they need to point to other city documents where these conversations are happening, so other documents focusing on these social issues. We also recommend that cities mirror the specificity they use when they set goals like those for greenhouse gas reduction, when they set their inclusivity goals. This will not only signal to youth that cities take climate justice seriously, but will also ensure that these goals are prioritized and that they're acted on in meaningful and measurable ways. Finally, we recommend that C40 look to better understand how cities engage with their education systems. Because climate education is rarely discussed in CAPs, we need more research to work through how best to incorporate the wide-ranging demands that youth have on this topic. But with that said, we encourage C40 to consider both formal and informal education opportunities and to look to cities like Washington, D.C. and Rio de Janeiro who have goals on this topic for initial inspiration. And with that, I want to say thank you for your time, and I'm happy to answer any questions.
Thank you, Alyssa, for an excellent presentation. Let me invite audience members to ask questions of Alyssa about this fascinating topic. We have a first question from Tiffany. Tiffany, if you want to unmute your mic and open your video, go ahead.
Hi, Alyssa. Thank you so much to you and your team for very robust and well-presented findings. You had mentioned in your recommendations the importance of setting specific and measurable goals for climate justice, but they seem hard to do. And I just want to know, are you aware of any cities that are doing that right now?
Yeah, so really interesting question. And I think one thing that was nice about going through the CAPS was just really seeing the different lenses that cities work through. So yeah, social goals are hard to set meaningful and sort of measurable targets on, but I think there are a couple of good examples that come to mind. So the first is Los Angeles that has a goal of ending street homelessness by, I think it's 2028. So it's a very specific goal with a specific target date. And then Seoul has some interesting examples as well on citizen science, where they call out a specific number of what they term green activists that they want to engage by a certain period in time. Yeah, thank you for your question.
Other questions for Alyssa? And as we wait, let me say thank you to Tiffany and all the other alumni who have joined us tonight. Any other questions for Alyssa? Okay, seeing none, I want to ask you a question, Alyssa.
All right.
I don't know exactly what the question is, but there's something here that's really, I don't know, gets me frustrated and excited, and I don't know what. It seems to me that the youth groups want more democracy, and they want climate action plans not to be simply about the environment, but to take account of equity and justice concerns, and that cities are simply behind. They're not as democratic as they need to be, and they're not as mindful of the importance of equity and social justice in their plans. Do you see it that way, having looked at so many of these plans?
I don't, it's an interesting question. I don't necessarily agree that cities are behind. Like, that's not the perception that I was getting in reviewing the CAPS. I don't think that's the perception that our team got. But I think there's a linkage problem where, I mean, I personally was surprised, I guess, to see climate and social justice raised so prevalently, with talks about Indigenous rights, about racial rights, a lot of focus on income inequality. That's just more vast than what I conceive of as climate activism. So I think cities are engaged on these other topics. I think they recognize the importance of pulling people out of poverty, of addressing boundaries and access. I just don't think they see it as a climate issue. So one of our other recommendations that didn't make its way into this presentation is really around communications, with the idea that I think cities are doing more than they get credit for in the CAPS on some of the key issues that you talk about. So they're, in addition to looking at how do you change climate action plans, there's this piece of how do you make sure that the actions that cities are taking or being moved to the forefront and talked about, so that youth have something to engage to in a tangible way, as opposed to this theoretical, we want democracy and we're not seeing it.
Okay, I'll take your word for it. Thank you very much. Congratulations. Great presentation, really interesting topic. So,
thank you.
This is a momentous moment in our history of final briefings in the Integrative Capstone workshop. To this point, you've been hearing presentations from students in the Sustainability Management program. The overarching purpose of that program is for students to learn ways to integrate sustainability concerns in the way that organizations work. And by organizations, I also include communities and cities and governments. Next, we will hear a presentation from a different program, the Master of Science in Sustainability Science. And there, the objective might be the same, but the means of getting to it are different. Here, the focus is on the practical application of science to help organizations pursue sustainability. So the students in this program focus on observing, analyzing, and predicting and addressing environmental impact using cutting-edge scientific methods and tools, and then learning to do this work for organizations. And so I'd like to invite our next presenter to give us an example of the work that takes place in the sustainability science program, and that's Kevin Webb, who worked with Dr. Ben Bostic and Cassie Shu this semester on behalf of Riverkeeper to look at microplastics in the Hudson River. Kevin, welcome.
Thank you so much. Can everyone hear me?
Yes.
Awesome. All right. Well, thank you so much for being here with us. And by here, of course, I mean wherever you are. We are the last to go up and the first of sustainability science ever. So it's a huge honor. And if it's okay with everyone, I'd like to just have fun with it. So let's take control of this. And there we go. All right. So here's our title slide. We had a team of 6 that was tackling the issue of microplastics in the Hudson River. And we had the privilege of working with an awesome client, Riverkeeper, which since 1966 has been a tireless advocate for the health of the Hudson River. So over the years, they have worked on a who's list of terrible pollutants, including oil, PCBs, sewage, fertilizer, and toxic waste. And they've done this through advocacy, through lawsuits, through citizen engagement, and through proposed policy. And we were working with them to see whether microplastics, there's a little bit of a delay, whether microplastics might be part of this long line of pollutants. So a quick overview of microplastics. You've probably heard a lot about them over the years. They're very broadly defined. The best definition we saw was that they were smaller than 5 millimeters, and beyond that, you can categorize them by whether they're primary or secondary microplastics. So what that means is primary microplastics come out already small. Secondary microplastics are bigger, and then over time they break apart into smaller and smaller pieces. They're difficult to categorize because they come in different shapes, different sizes, different colors. They have different chemical makeups because there are different kinds of plastic, all of which have probably different ways that they harm or don't harm individuals. And they also come with a slew of different additives to make them softer or harder. One of the reasons that we care so much is that in just about every type of aquatic organism that has been studied, microplastics have been found. And there are a lot of different ways that they could potentially cause harm. In certain studies, they've been shown to influence reproductive capacity, feeding behavior, and we also know that they can biomagnify up the food chain. So that means that every step up the food chain, you get more and more microplastics accumulating. The other reason that we care is that they're found just about everywhere that we've looked on the planet. So that tiny picture there is of scientists digging up microplastics in Antarctica, which may have gotten there through wind or through ocean currents or through some of those living organisms that we talked about. So in our project, what we wanted to do was focus on the Hudson River. So first we needed to figure out potential sources of microplastics in the Hudson where we'd be able to get a bigger signal of microplastics. Then we needed to look at those samples and measure the content of them, and then try to see what the types of microplastics were. And then last, we built some really lean methodologies for ourselves for sampling these different places. And we thought that we could transform those into ways that could empower citizen scientists to gather more and more data, because in the time that we had, there were just so many more questions, and we'd love to see more sites examined. Cool. So this is a little bit of a mess when it's this small, but I will take you through it. So there are a few different probable vectors of microplastics coming into the Hudson. So first is microfibers. You may have come across these. These typically often come from clothing, and they're long strands of plastic that break apart. These often get into estuarial systems through laundry machines. You've also probably heard about microbeads. These are tiny, tiny perfect spheres of plastic that show up in toothpaste and various cosmetic products. And then from the sewer, these different products can get into the water through wastewater treatment plants, which are not designed to filter these items out, or they can get in through combined sewer overflows. If you haven't heard of these, what these do is when there's a big rain event, they cause sewage to overflow into the Hudson. And they're gross, but they're very important in New York. The other types of microplastic that we expected to find were films. So picture a plastic bag breaking apart into very thin sheets, and fragments of plastic, which come from not just Lego guys, but all sorts of different bigger plastics that break apart. And those can get in through the sewer, but also through wind, currents from the Atlantic, for example, or from sediment where it's already settled into the dirt and comes back out. Cool. So the next thing that we had to do was we had to figure out good sites. So this is a picture of northern New York City, and the green dots are combined sewer overflows. I'm going to say CSOs from now on, but that's what those are. And the blue dots are wastewater treatment plants. So we narrowed it down very scientifically, and we chose 2 spots that were close to Columbia and 1 spot that was close to where Jeff worked. We also got a hookup for a wastewater treatment plant that sent us 24 hours worth of water samples. And if you're curious, that is what a combined sewer overflow looks like. And yes, it is gross. Cool. So picture this being a video of me going and sampling water and then dumping it through a sieve, which is this little metal thing that you pour water through, and then microplastics stick in it and the water goes out. That's the video there. For a week, we went out every day and we sampled those 2 spots, and we went out at slack tide, which is where water is neither coming in nor going out. We sampled 15 different times each time to get a total of 9 liters of water. And we used a couple different sieves to get different sizes of microplastics. This is our scientific walkthrough. So first we collected, then we got different sizes of microplastics. Then we had to try to get organic material out. That's a very common thing in estuarial systems, and it should be there, but it was not what we wanted. So we used a lot of bleach to try to digest it. Then we removed inorganics using a density separation. And then after that, we had to look through a microscope to see what we saw. We used a little bit of a dye to make the microplastics show up better. We categorized it by type, and then at the end of it, we got a nice Excel image that we'll show you soon. This is us doing science. And we got microplastics. So on the left is the first image that we got of microplastics coming out. It might be hard to see, but you can see a couple of microfibers, and you can see some things that look like they might be fragments. On the right, you see what it looks like with dye. So that causes the microplastics, which are often translucent, to show up better under a microscope. Cool. So this is what they look like at 200x magnification. So on the top left is organic material that was not digested. Top right, microfibers, things that come from clothing or other products. Microbeads, those spherical things that often come from cosmetics. Fragments, plastics that break apart, and films, the bags that we saw, and other thin types of plastic. So from there, we use the power of PowerPoint and circles to try to come up with a number of these different types of microplastics. So we went through the samples that we were able to analyze in the time that we had, and this is what it looked like. We had a number of us go through the same images to try to come up with a consistent number. And at the end of it, we got some interesting results. So in the 2 days of data that we looked at, we found that the biggest contributor to microplastics by far were fragments. So that's the big turquoise blob. I'm a little bit colorblind, but my team tells me that that's turquoise. And that shows up in both the Battery Park and the 115th Street sample sites. When we compare this to other published results, we show that that is in line with other studies. And bear in mind that other studies use different methodologies. We were looking at combined sewer overflows. We are way below the Clichy discharge site in France. But also bear in mind that we looked at this in relatively good weather. So we would expect that microplastics would come out far more if we had gone during a discharge event when there was a lot of rainwater that was causing sewage to go out. And in hindsight, I'm not upset that we didn't get to experience that. So from here, we were left with a lot of different things that we would love to explore if we had had more time, and that we hope other people can pick up. So first and foremost, we feel good about our methodologies. We'd love to see it further validated through future study. We'd love to see that our results are replicable. The second thing is we think that our methods could be really useful for citizen scientists. So we'd love to see the community try it out and see whether it works for them, people who are not technical. The third thing is more sites. So more CSOs, more wastewater treatment plants, but also industrial sites. Also places like the middle of the Hudson versus the edge. Also near the Atlantic where more seawater is coming in. There's so many questions because the Hudson is such a dynamic estuarial system, and it'd be great to get to more conviction around what the microplastic load looks like everywhere. Fourth thing, we found some really interesting evidence from a past Riverkeeper and Lamont Doherty project where tracers, which are chemicals that can be used to identify the origin of different places. So in this case, pharmaceuticals were found to correlate with CSOs or wastewater treatment plants. So if we could correlate microplastics with that, it could be an easier way to try to predict where microplastics occur. And then last, there was a lot of evidence also that animals like oysters can accumulate microplastics. So if we could partner with someone like the Billion Oyster Project and get oysters from different parts of the Hudson, then we could get a cumulative view of what microplastic exposure looks like. Cool. So just to talk a little bit about the DIY part. So this is what our own methodologies look like. We built it for us. Traveling on subways to different sample sites, we had as much space as a reusable grocery bag. So we built this collection jar. After the project, we designed some sieves. We used laboratory grade sieves, but that's going to cost hundreds of dollars, and we'd love to make it more affordable for scientists. And we're working on a website, which you can see in the top right corner there. We've already made an instructional video, and behind that is a little handy guide for trying to identify microplastics. So just to recap, we found microplastics. They're in line with other studies. There's a lot more to explore. And we've built a toolkit that we hope can be useful for answering some of those questions. And that's it. Thank you so much. We had a lot of fun working on this.
Thank you very much, Kevin. So questions for Kevin, please, from the audience. Okay, we have a first question from Dr. Chilrud. Go ahead.
Hi, yeah, nice presentation.
Thank you.
I might have missed it, but what was the goal of your client? I didn't hear you, you have a client. What did the client want out of this project?
That's a great question. They came with some fairly open-ended questions. There's an open question of how harmful are microplastics specifically to wildlife? And what we found in literature review was it ranges. The precautionary principle is probably warranted. Some microplastics are probably more harmful than others. But in order to answer those questions, we step back and you first need to understand what the burden of microplastics in the system is. So we had worked with the client and agreed that that would be a good place to start. From there, they also wanted a methodology that could be used for more ongoing study. So those were the two main things. There were a couple other questions along the way that we tried to answer as well.
Okay, the next question is from Dr. Jenna Lawrence. Welcome, Jenna.
Congratulations, that was wonderful. Two quick
you.
questions. Yeah, did you consider or take into consideration at all phytoplankton and zooplankton ingesting microplastics? And two, did you get any sense of how good our waste treatment plants here in New York are at getting rid of the various categories of microplastics?
Oh, those are both good questions. So the answer to the first one is we did not. We would have hoped that any microplastics that were present in phytoplankton would have shown up in our system after having been dissolved by the bleach. The second question, we came very close to potentially being able to answer with water coming out of the wastewater treatment plant, but unfortunately, we got about a day in the end in Lamont Doherty to analyze data before COVID had us all distributed. But it would be amazing to have water coming into a site and water coming out of a wastewater treatment plant. That would be so useful for understanding that question.
That was a question from the audience as well, so I'm glad you covered it by answering Dr. Lawrence's question. Dr. Bob Cook has a question. Go ahead.
Hi, that was a really interesting presentation. Thank you. I wondered if you could spend a couple more minutes talking about your methods. Is there a standardization amongst different scientists, that speak to depth? I mean, would you get more plastics the closer you got to the bottom? Were you trying to quantitate this? And then you mentioned seasonality, locations, and lastly, my question was whether the pandemic influenced this. Were you originally planning on 2 days of collection, or had you planned a lot more?
Those are all great questions. If I don't answer all of them, it is not out of rudeness, it is because I forgot one of them. So I'll expect you to
we'll see.
Chime in.
Get close, thanks.
All right, so the first question was about methodologies. And you'll notice in results, if we had published, shown all of the results we saw, the results for different estuarial systems in different cities are all over the map. And that was one of the first things that we saw, is that there's a lot of inconsistency in how these materials are generally collected. So often it ends up looking like a jar device. I actually have one. So thanks for giving me an excuse to use this prop. Going into the water, picking up water, and then running it through sieves. The other one that you come across a lot is dragnet, originally built for getting shrimp or other small organisms, krill, and then people can collect microplastic that way. If we want to have a better handle on which places are most affected and which times of the year and all of that, we need to have more consistent methodologies. So you've identified something key. What was the second question? I remember the COVID one.
Well, I think you covered a lot of the methods. Was 2 days your original intent?
Oh, great question. No, so we went out for 5 days, and then we went out again 2 more times.
Oh, okay.
So I didn't, yeah. And we, unfortunately, were only able to analyze 2 days worth of those samples.
I see.
Yeah. One other
so
fun
your
one.
design was originally, those 5, sounds like maybe 7 collection times. That's what the design of the project was. You did that, but you couldn't analyze it.
Yeah, we originally designed that to be both something that could yield interesting data, but then also sort of a baseline for our methodologies. And based on what we saw, we were going to test more sites. One other fun way that COVID affected us is a couple months ago, the biggest concern in New York was that we had one of our team members sampling sites in Battery Park. And there are a lot of people who get upset when you're in Battery Park and you're sampling water from the side. So we got to deal with some Battery Park cops as well. Science isn't always pretty.
All right, thank you very much.
And I'd like to thank you too, Kevin, for a wonderful presentation and for making the Sustainability Science program proud. Ladies and gentlemen, we have reached the end of our program tonight. I'd like to, before I let you go, do a couple of things. The first is to congratulate the students who have all not only done wonderful projects, but who have had to work under adverse conditions. And so they've shown a lot of ingenuity, perseverance, and have really demonstrated what they've learned as they've shown us tonight. So I'd like to thank them all and congratulate them for their projects. I would also like to thank the faculty advisors who worked with them all semester long, and there are 6 of them. Let me read out the names in no particular order. Professor Lynnette Widder, Suzanne DeRoche, Kizzy Charles-Guzman, Dr. Bob Cook, and Thomas Abdallah in the Sustainability Management Program, and Dr. Ben Bostic with help from Cassie Shu in the Sustainability Science Program. I really appreciate the work that you've done with these students. Your hard work was evident in the presentations we saw tonight. I just want to say that I've been doing this now for 9 years. This was an exemplary set of presentations. I'm very proud of this work. I think you've all shown how ready you are to be sustainability practitioners. To those of you who are graduating, congratulations, good luck, and do good work. Have a good night, everyone. Thank you for joining us.